I guess we are live now. Hello, hello, hello. Yes, we are live now. So, hello everyone. Today we would be discussing Codeforces round 916. Do you see? I will start with problem A first. Problem A says problem solving log. Monocap is participating in a programming contest which features 26 problems named from A to Z. The problems are sorted by difficulty. Moreover, it is known that Monocap can solve problem A in 1 minute, problem B in 2 minutes, and so on. Similarly, problem Z in 26 minutes. After the contest, you have discovered his contest log. A string consists of uppercase Latin letters such that ith letter tells which problem Monocap was solving during the ith minute of the contest. If Monocap has spent enough time in total on the problem to solve it, he solved it. Note that Monocap could have been thinking about a problem after solving it. Given the contest log, calculate the number of problems he solved during the contest. Like, let's see what does the problem statement says. Like, a simplified problem statement says there is a contest with 26 problems of character A, B, C, just like usual Codeforces round. And it takes Monograph 1 minute to solve it, 2 minutes to solve it, 3 minutes to solve C, and so on, 26 minutes to solve that. And we are given that a series of events where Monocap is spending time solving some problems. For example, first sample test case A, C, B, C, B, C. It means in the first minute, Monocap was thinking about A. On the second minute, he was thinking about C. On the third minute, he was thinking about B. Fourth minute he was thinking about C. Fifth minute he was thinking about B. And sixth minute he was thinking about C. So if we look at the total time he has spent on solving A is 1, B is 2, and C is 3. And we can see like that's the only time he needs to solve this problem. So he would be able to solve all three of the problems on this test case. Similarly, let's look at the next sample test case as well. Next test case is A, F, E, C. If you look at the total time Monocap has spent on A, it's 4 minutes. On F, he has spent only 1 minute. On B, also 1 minute. And on C, also 1 minute. So, although he would have solved A on the first minute, he wasted 3 more minutes thinking about A again. While for F, he needs 6 minutes. For B, he needs 2 minutes. And for C, he needs 3 minutes. So, he won't be able to solve these three problems. And hence, the answer is 1. Now, I will go through my code for this one. Like, I just created an array of size 26 and I am subtracting a size, like I am just using the ASCII values for the string. So x minus this will denote that for at the 0th index I will maintain time corresponding to the problem here, and on 25th character I will maintain time taken on the problem Z. And then I iterate it using an array of size 26, and I am checking like whether, like, since it's a 0 based index, I'm checking if a person has index I plus 1 time on it, and at last printing the count. Any questions on this one before I move on to the next problem? I will move on to B now. Same problem story over here. Monocap is practicing for a big contest. He has planned to solve n problems to make sure he is prepared. Each of these problem has a difficulty level. The first problem has difficulty level 1, second has 2, so on until nth problem has difficulty level n. Monocap will choose some order in which he is going to solve all the n problems. Like this time, instead of 26 problems, there are n problems. And he will choose some order, like we know that he can solve all of the problems, and he will decide the order in which he will solve the problem. Whenever he solves a problem which is more difficult than the last problem he solved, he gets excited because he feels like he is progressing. He does not get excited when he solves the first problem in his chosen order. For example, if Monocap solves the problem in order 354162, he gets excited twice corresponding to the problems which are underlined. When he solves problem 5, the problem which he solved just before 5 is 3. When he solves problem 6, the difficulty of problem just before it is 1, which is less than 6. While if we compare 5 and 4, for 4 the problem before it is 5. Monocap wants to get excited exactly k times during his practice session. Help him to choose the order in which he has to solve the problems. And now we are given the constraint that n and k are up to 50. And we have to output n integers from 1 to n, denoting the order in which Monocap should solve the problems. If there are multiple ways which Monocap can do it, we can print any of the order. And it's also given to us that under the constraints of this problem, the answer will always exist. Now let's look at the sample examples over here. Like for the first sample, the order in which Monocap solves is 354162. It's the same as the one which we previously discussed and described in the problem statement. You can see that like on first he can never get excited. For 5, 3 is less than 5, so he will get excited over here. While 4 is not less than 5, so he will not get excited over here. So that 2 times when he got excited was 5 and 6. Similarly, let's look at the second test case once. 2 is less than 1, 3 is less than 2. Sorry, 1 is less than 2, 2 is less than 3, 3 is less than 4, and 4 is less than 5. So he will get excited at 2, 3, 4, 5. And similarly, we also have an example of 5, 4, 3, 2, 1. So he will not get excited at any point of time, hence the answer is 0. So to think about this problem, since it's a constructive problem, we can think of a way and there are multiple possible answers. If we are able to find one way which we are able to solve, then we are good. And one of the way which I chose was, we know that Monocap cannot get excited on the first problem. Then I chose the order in which he will get excited k times, and then he will never get excited. And one idea was to create this array of numbers in increasing order and create this array in decreasing order. And also note that we have a character n with us. And if Monocap solves any problem before n, then because n is the largest number, he will get excited. So in case, I will work on the audio quality. I have ordered a mic which would be available with me for the next stream. So the idea is we can fill the numbers starting from n over here. And then we can fill the remaining numbers in the decreasing order over here. So if I look at the initial example again, does this help? I have kept it on the table. Is it better now? Like I have removed it from my side, like the mic which I have. And like if I look at it, like let's pick up some sample test case over here. Let's say we have n equal to 9 and k equal to 3. And one possible way here can be like we first fill four numbers 9, 8, 7, 6, and then rest of the numbers in decreasing order. Here he will get excited at these three times. This was the order I chose. And now moving on to my submission for this. Pretty much the same order. I printed like where k is the number of times he wants to get excited. I printed k plus 1 numbers, largest k plus 1 numbers in the ascending order. And the remaining numbers, 1 second. This was the one where I got to WA. So I printed numbers in the ascending order and then the remaining numbers in the descending order. And that was the way. Like any questions on this before I move on to the next problem? Let's move on to the next problem now. Monocap is playing a computer game. In order to level up his character, he can complete quests. There are n quests in the game, numbered from 1 to n. Monocap can complete quests according to the following rule. The first quest is always available for completion. The quest is available for completion if all the quests with j less than I have been completed at least once. Note that Monocap can complete the same quest multiple times. For each completion, the character gets some amount of experience point. For the first completion on the ith quest, he gets AI experience point, and for each subsequent completion of ith quest, he gets BI experience point. Monocap is a very busy person, so he has to he has free time to complete no more than k quests. Your task is to calculate maximum possible experience Monocap can get if he can complete no more than k quests. Now let's first go through like what does this problem statement mean. Like Monocap has some quests. Let's call them 1, 2, 3, 4, 5, 6, 7. What he can do is like A is unlocked at initially, and whenever he unlocks the ith quest, he whenever he completes the ith quest, he has unlocked the I plus one quest as well. So, for example, if we want to complete the fourth quest, he will have to complete 3 and 2 before it. We are also given that the very first time Monocap completes a quest or like let's say something, then he gets AI point, and if he repeats continuously doing it, he will get B1 BI next time. And we are given that Monocap can solve complete at max k quest and the maximum experience sum of these integers he can get. And now let's look at the sample again. Sample is he can complete 7 quests at max. For the first time, if he completes 4, 3, 1, 2, the sample claims that the best case scenario would be to solve it in this order. When he completes one for the first time, he gets 4 points. Next time he completes, he gets 1 point. Next first time when he completes two, he gets 3 points. Then first time when he completes three, he gets 1 point. Next time he completes two, he gets 1 point. First time he completes two, he gets 4 points. The next time he completes two, he gets 1 point. And this will be equal to 30. Now let's see like how do we solve this problem. Like one possible way of doing is like we know that there is a dependency. Like first is unlock every time. If we know that monocap has solved the ith quest, then he has solved everything until I at least once, and these are the remaining ones. And let's say he has solved these are the only quests he has solved. Like after solving every one of them, then he should repeatedly just choose the maximum bi, because we want to maximize the value final value over here. If he has solved I distinct quest up to I, then the number of points he will get is a1 plus a2 plus ai, and after solving these I, he will have k minus I quest remaining with him, and for that he should use greedy and choose maximum value of. And once we have this algorithm, we have one order n square algorithm, and we can even optimize it to order n, where we iterate over the I number of quests he has solved at least once, and then choosing and maintaining a variable which maintains this maximum. Now going into the code for it, like we take input over here, like I am maintaining a vector of pairs VII. Here I have defined as vector of pair. For the first element, I am taking first part and the second part, and then I am iterating over the array starting from the first one, adding AI first and subtracting that from the k, and for the and also maintaining a max variable over here, and at last maintaining the sum so far plus the maximum we have found so far. And if we run out of the quest, we break over here, and at last print the maximum over here. Any questions on this one before I move on to the next one? Like one of the question asked is iOS sync and C in Thai part necessary? Like will it save significant times? Like it depends on the input size. Like for example, here we have one E5 character, but if we need one E6 character or something like that, then C in C out can significantly be slow over here. And like one more thing which you should look out for is you should define has define lesson. Like someone asked like how do we get intuition for the C1? Like the idea was if we fix the set of problems which monocap has solved, like, on the intuition part, since there are different cost functions for AI and BI, if we somehow fix the number problems which monocap has solved, let's call them S1, S2, S3, SK, then we know that solving one of them, we like we will have to add A for all of these, like AS1 plus AS2 plus ASK. And because we want to maximize the number of times number the final value we have, we should also pick the maximum, like then we should only pick the maximum bk over here among all these. And because we are given that the order of solving is one, only after solving one can solve two, and only after solving two one can solve three. So we know that S1, S2, Sk would be 1, 2, 3, 4k as well. So like one of the question asked is, in Codeforces, is it possible to get explanation? Like they do publish blogs over there. So like if you look at the previous contest, right? This is their homepage. Last contest is not available. Before that, every front page has a line. Editorial is available over here. Here you can find their explanation. Any questions on C before I move? Okay, can I explain the third test case? Okay, third test case. One, two, and total we have is 5. So let's say we solve only the first problem. In that case, our max value we can get is 3 plus 4 into 2. And let's say we have solved at least two distinct values over here. Then our cost would be 3, solving it once, solving it 2, and the maximum of these two multiplied by 3. Maximum is 3 over here. In this case, the max cost would be 8, 11. In this case, the max cost would be 14. Let's say the number of distinct problem you have solved is 3. And the cost, like the maximum experience you can get is 3 plus 2 plus 4. And used rest in peace. Sorry, I forgot to switch my screen. Okay. I will start explaining 3 again. Like so far, I have written A and B values. And let's say monocap has solved only one distinct problem. In that case, the maximum cost he can get is the cost for A with solving the first problem once, 3, and he has 4 still problems, 4 more times he can complete it. So the maximum cost he will get is 4 plus 4 into 2. And let's say he has solved two distinct problems. Then the maximum experience he can get is sum of these two plus 5 minus 2, which is 3. So 3 times maximum of any number value over here. So this will be 14, this will be 11. Let's say he has solved 3 distinct problems. Then the max cost he will get is sum of these, which is 3 plus 2 plus 4, and the 2 times maximum of this, which is plus 2 into 3, which is 15. We can also check the rest of the part. Like if he solves 4 distinct problems, then the cost max experience he can get is sum of these plus the maximum over here. Which is 3 plus 2 plus 4 plus 1 plus 1 into 4, which will be 14. And if he solves maximum all of them, the experience he will get would be 3 plus 2 plus 4 plus 1 plus 4. And he won't be able to solve any cost quest 2 times. So, any questions on this one before I move on to the next problem? So, the next problem is 3 activities. Winter holidays are coming up. They are going to last for 10 days. During the holidays, probably I can, yeah, I went through the code. During the holidays, Monocap wants to try all of these activities exactly once with his friends. Go skiing, watch a movie in a cinema, play board games. Monocap knows that for the eighth day, exactly AI friends will join him for skiing, BI friends will join him for a movie, and CI friends will join him for a board game. For board games. Monocap also knows that he can't try more than one activity in a single day. Thus, he is asking you to help choose three distinct days XYZ in such a way that total number of friends joining for the activities AX plus BY plus CZ is maximized. So like let's see like what does this problem statement ask us to do using the sample. Like there are three types of activity which monocap can perform. Like let's and like where X can be go skiing, Y is watch a movie, and Z is play a board game. And there are different friends who would be coming to his home in winter. Like for example, on the first day, one friend will come for skiing, 10 friends will come for movie, and one friend will come for board game. Similarly, on the second day, 10 friends will come for skiing, one friend will come for movie, and one friend will come for board game. And on the third day, one friend will come for skiing, one friend will come for movie, and one friend will come for the board games. And monocap can do only one on each day. Monocap can either go for skiing or go for a movie, or he can go for like board games. And we are asked to find the maximum number of friends he can take with him for the show. And in this example, as we can see, like this would be the maximum. First day he should go with 10 friends for a movie. Second day he should go for skiing with 10 friends. On the third day he would should go for board games with 10 friends. So like that's the first sample. Like and now moving on to the solution part. Although it was not required during the contest, I coded a bitmask TP for it. But there is a simpler solution for it. Like the idea is we can we can find the maximum values, maximum three values for each of them. Like, because like monocap can have collision only two times with something else. Like let's say for the time max value is a1, as1 for as2 on as3. Like probably it can be the case that on this day he went for board game, on this day he went for movie, but this will definitely be free over here. So the idea is for each of the three vectors find the indexes where something is maximum and then run and those number of such distinct indexes can be 9, and then you can run a 9 cube solution algorithm for it. I will skip my code for it, but let me check sending someone would have done it. And if we see English solution, what he did was he read input in ABC, then he created three vectors which has indexes 1 to n, and then he sorted like filled everything with 1 to n, and then he sorted them in the decreasing order for ABC. So now PA of I contains the largest value of A. PB of 0 contains the largest value of B and C. Then he ran a 3 cube solution over here. And like if all of these are distinct integers, he took a sum over. Like there are overkilling solution. Like someone in the chat said they did recursive DP. I did a bit mask DP for this one. So, yeah. So any questions on this one before I move on to the next problem? Like this is in fact greedy, like taking only the largest C value. Okay, moving on to the next problem now. So for the next problem, what we are given is Alice and Bob's are like there are two subtasks, and it's given that the difference is only on the number of test cases and the story remains same. So I will start with the harder version itself. Yeah, like I know they do not expect bitmask DP for div 3D, but it was like I instantly realized it and I thought like it's faster to code it than solving. Recently, Alice and Bob were given marbles of n different colors by their parents. Alice received A1 marbles of color 1, A2 marbles of color 2, and AN marbles of color n. Bob has received B1 marbles of color 1, B2 marbles of color 2, and until BN marbles of color n. All AI and BI are between 1 and 10 to the power 9. So, like everyone has received at least one color marble of each color. After some discussion, Alice and Bob came up with the following game. Players take turn, starting with Alice. On their turn, a player chooses the ice such that both players have at least one marble of that color. The player then discards one marble of color I, and their opponent discards all the marbles of color I. The game ends when there is no color I, such that both players have at least one marble of that color. The score of the game is difference between the number of remaining marbles that Alice and Bob has and the number of remaining marbles that the Bob has at the end of the game. In other words, the score is equal to A minus B, where A is the number of marbles Alice has and B is the number of marbles Bob has at the end of the game. Alice wants to maximize the score and Bob wants to minimize it. And calculate the score at the end of the game if both play optimally. So I will go to the puzzle now. Like let's pick the first sample where the score is 4-1-2-2-1. And if I look at the explanation, it says on the first term, Alice should choose this color. So the color here, he would remove only one color and Bob will do everything over here. And then when it's Bob's turn, he should choose this one so that Alice marbles become 0 over here and Bob's marbles becomes 3 over here. And on the next turn, Alice does not have a choice. So he will make choose the second color. Then Alice will have only one remaining marble over here and here Bob will have 0 marbles. In the end, Alice will have 3 plus 1, 4 marbles and Bob will have 3 marbles. And the final score would be 1. And probably let's look at the second sample, like that would be better. I have ordered a new mic regarding sound, so next time we would have something better, I hope. Before Zoom kicks out, like, let's look at the second sample once. It's 100, 20, 15, 110, and 2020. And for this optimal case, the order in which like Alice should choose this color first, so that the number of marbles Bob has of color 1 becomes 0, and the only marble he has also becomes 0. And Bob's turn, Bob should choose these colors, so that Alice's marbles on of type 2 becomes 0 and Bob's marbles just decreases by 1. And on the third turn, Alice should choose the marbles of color 4. So his marbles becomes 19 and Bob's becomes 0. Now Bob does not have a choice. So he chooses the remaining color, it becomes 0 and his marbles becomes 9. So Alice will have 0 plus 0 plus 0 plus 0, 19 colors. And Bob will have 0 plus 14 plus 9 plus 0, which would be 23, which is minus 4. But wait, the answer is minus 9, so Bob should probably choose a different marble on his turn. Like in the first turn, so Alice does not have a choice. He should pick the color one only. Like let's say what happens if on the first turn of Bob chooses this. In this case, his marbles here would be 9 and this would be 0. And then if Bob chooses this, his score will be 19 and this will become 0. And then Bob chooses 20 and 50. Like Alice's score here would be 0 and he would have 14 over here. Probably this is also the wrong one. Like let's see if what if Bob chooses 2020 in the next one. This becomes 0, this becomes 19 and if Bob chooses 2050, this will become 19, this will become 0 and in finally Bob chooses this one. Like let me do it. On the very first turn, Alice chooses the color one. So his score of his marbles of color type becomes 0 and Bob's also becomes 0. On Bob's turn, Bob should choose the color 4, so that Alice number of marbles Alice has of color 4 becomes 0 and Bob becomes 19. And on the third turn, he should choose color of 19 and on Bob's turn, he should choose the final remaining one. So in this case, his score will be 19 minus 20, 9 plus 19. Like, this is how the game is working over here. Any questions on this one before I move on to like how to solve this problem? In fact, like so far, what we have done is understood like what does the problem statement ask. Like I haven't really decided how to play optimally yet. Like what I have said is like, oh, how does the game looks like? So like first thing to notice in the game like this is in the end all the stones will be chosen. Then only the game ends. And Alice and Bob does not really care about the number of stones they have. Like the only thing they care about is difference of the stones with respect to the other. and they want to maximize their difference. So like let's pick a particular marble AI, let's say, and its corresponding BI. If Alice plays a move on this one, the final stones on this one would be AI minus 1 and BI would be 0. And if Bob chooses stones on this one, the final stones over here would be 0 and BI minus 1. This, like if we say our final score function is S, then it's at plus AI minus 1, and this one subtracts BI minus 1. So if, and because like we can even change this something over here. Like we can say that Bob has already chosen, like in the final case, either plus AI minus 1 will be added, either AI minus 1 would be added to the score, or BI minus 1 would be subtracted from the score. And if we look at it this way, like either one of thing will happen. So overall, if we look at the score, like either, and like if we have some score as based on the other games, either final score would be S AI minus 1 or S minus BI minus 1. So this game essentially contributes, like the difference between these two. The difference between these two is AI plus BI. If it's Ali's turn, he can make the final score better by AI plus BI if he does not allow Bob to play over it. So the final solution here would be, or we can look at it the other way as well. Like let's assume that Bob has chosen all the stones which he wants to take. In Ali's turn, Alice can snatch one specific color from Bob and replace that with AI minus 1 comma 0. And when it's Bob's turn, what he can do is he can hook fits stick those stones in his pocket. So they can keep doing this until all of the stones have been kept in their pocket. So the overall solution would be, we should sort the given integers in this way, and then we will have a clear strategy which is the best possible stones to pick for now. And in their alternative turns, Alice and Bob can alternate between them. Now moving on to my code for it. So I sorted it. Like I found like how many stones Alice can get by a particular strategy. Like if I am comparing two numbers. Similarly, I found like number of stones Bob can get. And then I similarly did for the second over here. And like I chose the one which contributes better to the song. And then alternated between both of them. So the idea is the constant to the score. Like if I compare two like the main idea is like how do we decide if like in the games like this, what we have to do is we have to take two specific files. Let's say we have only two colors to pick it up. What should be the one which Alice should pick over here? If he chooses color one, he will add this to the score. In which case, Bob will get this one. And other way around for the Bob, if he chooses the other tile first. Which one gives us the maximum score over here? In this case, the final score would be, and in this case, the final score would be A2 minus B1. If this is higher, then Alice should go for this one. If this is higher, Alice should go for this one. And like that was my idea. Now, if we have two piles based on the value of these two integers, we can find which is the best strategy for both of them. Any questions on this one before I move on to the next? Um, Now moving on to the next part. Moving on to F now. F says Burstoff is the biggest IT company in Berlin. There are unemployed at Burstoff company number from 1 to N. The first employee is the head of the company. He does not have any superiors, and every employee I has exactly one direct superior. Employee I is considered to be superior or direct or indirect of employee Y if one of the following conditions holds. Employee X is direct superior of employee Y, or employee X is superior of direct superior of employee Y. To cut it short, what we can assume is there is a company, there is a CEO of that company, and everyone has one manager with them. And now there can be a change. Someone can be manager of someone. And now a programming competition is going to be held soon. 2% teams should be created for this purpose. However, if one employee is in the team of superior of others, like what it's they are uncomfortable together. So what it's saying over here is like they are going to organize a competition where teams of two should be formed. It should not be the case that someone is manager of someone in the team. And we have to find maximum possible number of teams we can create using this rule. Now let's look at the sample again. In the first sample, we are given that one is the CEO of the company. In the first sample, the reporting chain looks like this. Manager of 2 is 1, manager of 3 is 2, and manager of 4 is 1. And based on the answer, like we can one like we cannot choose team like 2 or 3 or 2 or 1 because someone is manager of other. But we can have a team like 3 or 4 or 2 or 4. So the maximum number of teams we can form is 1. Now moving on to the next one. Like let me pick the last sample as well. It says the reporting chain looks like this. Manager of 2 is 1, manager of 3 is 2, manager of 4 is 1, manager of 5 is 1, manager of 6 is 1, and manager of 7 is 2. And if we look at it, one way to form, like, we cannot have a team with 2 and 3 together, but we can have teams like this 2 or 4, 3 or 5, and 7 and 6. So the answer was 3 in this case. Any questions on the problem statement itself before I move on to the solution part? Okay, next. Moving on to the solution part. Like, let's say the tree looks like this. One is the parent. Like, there are some number of nodes over here. 2 is over here, let's say. 3 is over here. There are some number of nodes. Like, if like we know that total number of employees excluding one is n minus 1. If none of these is more than n minus 1 by 2, then I claim that it's possible to form maximum number of teams where everyone is in team apart from one. That is the maximum number of team one can form is n minus 1 by 2. Idea, the way we can do is, let's say the number of nodes for each of them is, here let's say there are 5 nodes in this subtree, there are 4 in this subtree, there are 3 in this subtree, and there are 6 in this subtree. We can always pick the maximum two and form a, say, a team using them. So we pick anyone from here and anyone from here and create one team. So the remaining people in this graph and this graph would be 5. And then we again pick the maximum, let's say 5 and 4. Here it will become 3, it will become 4. Then pick maximum again. And if you keep doing it, if the total number of people is odd, you will have one extra person left. And if it's even, you will have a perfect pairing. While the other case, let's say there are total 11 people. One of them is here. There are 7 people over here. One over here. And there is no way we can pair everything from 7 with itself, because more than half of the people are here. So the idea is we will choose 3 random people from here and pair it with these people. And we will have to find like what should be done with the 4 remaining people over here. So if the ask is if there is a way we can make a team using 2 teams using 4 people, and the remaining 3 can be paired up with these. And now this gives us a recursive algorithm to solve over here. Where we start with a top of tree, let's say we have some E as the extra number of people. Like they are outside this, but not in someone's hierarchy chain, the node at which we are at. In this case, we can pick one person from this extra to pair up with the head over here. And then we can find the tree which has maximum people over here. And the same idea holds. Anyone from this side can be paired with anyone here, or anyone here. So the total number of remaining people, if the maximum does not contain more than the sum of these, then the initial claim which I made, like I can always pair everything between them. And if this contains more than, like let's call it A1, B1, B2, B3, like the number of people in each subtree. And we are given that B1 is greater than B2 and B3. So if B1 is less than equal to A1 plus B2 plus B3, then we can always pair everything between them, like the way choosing two maximum among all four of them. And if B1 is greater than A1 plus B2 plus B3, then we should look at the B's children again and process the same recursive, assuming that these are the extra people we can have, which we can pair everything again. And I will move on to my code for this one. Yes, the idea of max and rest sum has been used multiple times. Yes, B1, B2, B3, A1 is the size of subtrees over here. So like now moving on to the code, I read all the edges first, and then I wrote a DFS solution, like inline DFS solution, computing the subtree sizes of all of the nodes, and even sorted the adjacency list over here based on the size, moving the maximum first. And then I'm again doing a DFS where this rest is the number of extra people I have. So like at first, if I have some extra people, I pair them up with the root and add +1 to the answer. And then I look at the remaining people in that node subtree. If it's less than equal to the number of extra people I have, I can always pair them up one and the other with the rest of the part. So that I directly add answer plus rest by 2, like assuming odd and even parity. Otherwise, I no longer have a child over here, then I just do rest by 2. This will happen only if rest is 1 over here. Like rest is 0 and I have basically paired everything over here. Otherwise, I look at the largest side, find the number of size of subtree of largest, remove it from the rest. So basically, this value gives me B2 plus B3 in my example. And this is the extra people I have, and I do the same part recursively. And at last, I am printing the answer I have. Okay, my initial claim was, like, let me first start with root as one, and there are subtrees over here, and each of them has some subtree size. Let's call A1, A2, A3, A4. And let's say sum of A1 plus A2 plus A3 plus A4 is 20. And all of these numbers are less than equal to 10. And my claim was there would be some way to pair everything between these over here, and the total number of teams we can get is 20 bytes. And the way, and one possible way to do that was, like, let's write these numbers here with sum up to 20. Some example is 7, 6, 5, 2. Then idea was pick the largest two and pick random one person from them and make a team with them and continue doing it. So, and then you pick largest again. Looks like I missed two over here. Like you will eventually will be able to pair it up. While at the same time, if any of them is greater than 10, and because the sum is 20, at max one can be greater than 10. And in this, let's say the example is 13. In this case, irrespective of how you pair, these 8 people, rest of the people can pair up with 8 people only. So the idea was like we find out some ways to pair seven. Okay, not eight, seven. These 7 people can pair up with only 7 people over here, and 6 people would have to pair among themselves over here. So idea was if we can somehow pair 6 people in this subtree, then the remaining 7 can be used to pair with these people. This was how we process the root, and the idea is similar for as we go down over here, assuming the things over here. Like that was the main claim. Now, I do not guarantee that the 6 are valid. Like it can be the case that we can only pair 4 people over here. In that case, we would be able to form 2 teams over here and 7 teams with these people. And the answer would be 9 instead of 10. The main idea is greedily try to find 6 people over here and pair the remaining ones over here. If instead of 6, I can only pair 2, then the number of teams would be 8 only. Because, and this is also a greedy part over here. If we, let's say we form a team, 2 teams among these, and we have only remaining 3 over here, and we will have to somehow pair the remaining 10 people over here. So 7 is also not guaranteed. Yes, 7 is at least guaranteed because these 7 people can be paired with random 7 people in the subtree of 13. I will move to Gina. So if you have any questions on this one, you can ask before I move to Gina. Yes, the idea is you do some greedy or like try to find pair maximum number of teams you can form in the larger subtree, and the remaining ones can be paired up with anyone from any of the subtrees. So moving to the next part, we have two subtasks again, G1 and G2. Like the question is, can it be solved using maximum matching? Answer is you can obviously try to do maximum matching over here, but this 2E5 can lead to TLE over here. Like had it been let's say only 100 people, then some maximum matching using max law or something could have gotten AC over here. Because for every 2 people we know either someone is manager of the other or they are not. And if they are not, then they can be matched. So we can get an edge between them. So moving to problem Gina, like it also had two subtasks. Like I will first discuss the easier part and the larger part. Let's read the story first. There are 2 light bulbs arranged in a row. Each, each light bulb has a color of 1 to n and exactly 2 light bulbs of each color. There are 2 light bulbs arrayed. Okay, initially all the light bulbs are turned off. You choose a set of bulbs S that you initially turn on. After that, you can perform following operation any number of times. Choose 2 light bulbs I and J of same color, and exactly one of them is on. Turn on the other one. Those three light bulbs I, J, K such that both the light bulbs I and K are on and have the same color, and light bulb J is between them, and turn on the light bulb J. You want to choose a set of light bulbs L that you initially turn on in such a way that by performing the described operation, you can ensure that all the light bulbs are turned. And we have to calculate two number over here. The minimum number of light bulbs we should turn on, and the number of sets of that minimum size modulo something, because this number is very large. Like now let's look at samples again. Like the first sample is 2211, and here the claim is the minimum set of size should be 2, and there are 4 ways to choose a set, and it looks correct as well. Like either we can choose this two or this two, but we have to choose at least one of them. So there are two choices for color 2, and we have to choose any one of these two. So there are two choices. So total 4 choices, and we have to choose two colors. The interesting one is the last sample. Like 3, 4, 4, 5, 3, 1, 1, 5. Like we can notice that because 2 does not lie between any of them, so we will have to choose at least one of color 2. And there are two choices over here. Similarly, we can see that choosing one coloring initially turning on one will only color the other one, and it cannot influence the rest of the ones. But if we are able to color, let's say 5 or any of the other color, then we can automatically color one as well. So like we should not color initially one, turn on the color one. Similar is the case for 4. We should not color it up initially. Now what we have been left with is 3, 5, 3, 5. And we can see that if we color any of them initially, let's say we have colored 5 initially, and in the next step we can also color this 5, and then we can color this 3 because it lies between these 3, and because we have colored this 3 we would be able to color this 3 as well. So coloring 5 initially will ensure that we have colored 3 and 5 as well, and then because we have also colored 3 we would be able to color 4 here as well, and because we have colored 5 we would be able to color these as well. So like that's how we do this part. Like how do we generalize it is a different story altogether. So any questions on the problem statement to begin with? So like now moving on to the next part. Let's compare two different colors, I and J. And the question ask us the question, if we color turn on I initially, can we turn on J automatically? And this will happen only if there are between the two eyes. If we color the first one, we would be automatically able to turn on the second one. And if there is a J which lies between them, or both of the J lies between them, and we would be able to turn on them as well. This is valid. This is valid. But J. If we create a directed graph where there is an edge from I to J, if I is turned on and J can be turned on automatically using I. and we can see that we will have a graph which will have some edges. The number of edges can be up to order n square, and it will have like, let's say this is how the graph looks like. And the main thing we have to do is we have to pick one color in such a way that we are able to pick all of the colors here. Like assuming that one is the only set size we need over here. So this gives us an idea of strongly connected components. And like if we look at the strongly connected components like this, since it's the last problem, it does have a prerequisite, like you should be knowing what is strongly connected component. And if we look at the SCC graph, there would be some set of source nodes. Like generally, this is how the nodes look like. There are a bunch of nodes which can be reachable from each other. And the idea is we should pick one from each of the source set. And pretty much that's what I did over here. Like I created a graph where there is an edge from I to j. If I turn on I initially and j can be turned on automatically. And there and with only this observation you will be able to solve G1 in order n square. So like someone asked like basically number of source SCCs. No, we need number of source SCCs over here. Like there can be a graph like this. In this case, we should not turn on any light for 5 and 6 because turning on 1 or 2 would be able to automatically turn on 5 or 6. Like every SCC which does not have a parent over there. The idea is if we compress SCCs, we get a directed acyclic graph. And like problem G2 was more harder. Like, I would rate it at least due to C, D1C, sorry. Like for this one, yeah, like if we compute the SCC and compress them into the DAG, we should count the number of nodes on that SCC. Like if there is a DAG, there should be some nodes which will not have an incoming edge. Like basically count the number of nodes which do not have incoming edge. Like that would be the minimum number of set you will have to pick it up. And in any such SCC, you can pick any of them. If I look at the example over here, so 1, 2 is the SCC. Like if we compress it, this graph would look more like this. So we should pick 2 and these two SCCs because 1 and 2 will automatically light up 5 and 6. I will try to wrap G2 a bit faster, like Zoom has been. So the idea was let's look at our original timeline as well. Like there are 2n colors. So let's create a new graph where there are 2n index and n colors. And we create an edge from I to j. If pj is I, like at jth index we have color I, and if color I is at place, let's say C1 and C2, like do it in the reverse. If the index j is colored, and if let's say at j we have color I, then we know that we will be able to color I now. And then reverse edges as well. Like if color I is at place C1 and C2, we create edge from color I to all the indexes like C1, C1 plus 1 until C2. Like overall there are 3n nodes here. N of them denotes to belongs to colors, and 2n of them belongs to index. This is still order n square, but now finding the SCC over here will give us the same result. Like any questions on like how do I create a graph on index and nodes first before I try to simplify it more? Okay, the next idea was we can even represent these end nodes as a segment tree over here. Like probably Zoom will kill me. Let me try to create a new meeting first before I move over here. Okay, I will take this example again, removing these two over here. So we have a bipartite graph over here, where on one side we have index, and on the other side we have colors. So taking the second example, excluding 2, we have 1, 3, 4, 5 as color, and then we have indexes 1, 2, 3, 4, 5, 6, 7, and our original graph line is 3, 4, 4, 5, 3, 1, 1, 5. So because 5 is present at index 4 and 8, we create a edge like this. because 3 is present at index 1 and 5. The idea is if we are able to turn on 1, then we would be able to turn on all the lights of color 3. 4 is at index 2 and 3. So we create an edge like this. And 1 is at index 6 and 7. So like these are the edges from index to colors. And now we can do the opposite as well. Because 5 is at index 4 and 8. So using 5, if we are able to color 5, then we would be able to color everything over here. Because 3 is between index 1 and 5, we would be able to color everything between 1, 2, 3, and 4 and 5. Like color 2, I just removed it from the graph because it was not helping over here. You can create 9 and 10 and nodes for them as well. And because 4 is between 2 and 3, we would be, if we are able to color 4, we would be able to color everything between 2 and 3. And because 1 is at index 7 and 8, if we are able to color everything, we would be able to color 1 and 7. Like I can also add 2 over here. But this graph would look mostly like this. The idea for putting index to color is like this does not help us right now in any way. The solution is still order n square. We have now have 3 n nodes for SCP instead of n nodes. But now we will try because everything is in a range over here. Like from this side to this side there are 2 n edges, and from this side to this side there are n ranges. And we will then, although this each range can be of size n, we will now figure out a way to simplify it to reduce the number of edges for these ranges over here. Like there would be some neat trick over here to simplify these ranges to have only log n edges instead of order n edges for a range of size n. Before I move on to the next part, like did you understand like what I am trying to create over here with adding more edges over here, and like finding the STC on this one will solve our problem. I understood the creation. Like for STC, probably I will leave it as the homework now. And the next part was, let's look at the ranges as a segment tree over here. Like we can create, like let's say we have 10 edges, then we can create a segment tree. Now what we know is that each range can be created using two n nodes over here in the segment tree, two log n. So if we create a graph with four n nodes, let's say, where we have edges like this already created between them, then if we have to create an edge from, let's say, color 3 to range 5 to 8, and instead of creating four edges, we can create edges over here like color 5 to this index, color 5 to this index. So instead of creating four edges, we would be able to do it using two edges. Like that's the idea. Because ranges are continuous, we can compress them in a segment tree somehow, and instead of getting the edges which is length of range, we can make it order log n. And like that's essentially the idea. And pretty much my code is doing the same thing where I'm creating segment tree, and probably I'm trying to cut it short over here. Like SCC would be a prerequisite for solving this. Like my expectation is the difficulty of this problem is at least D1 C over here. I can take some more questions if required, or otherwise, like it's been 1.5 hours, we can close now. Like, can I explain why we take range? Like, it's a kind of ad hoc problem, and range is trying to help us reduce the number of edges. Because for G1, an order n square algorithm works. For HCC, which has only colors, works. But we need something better for the second part. And range was one way using which I was able to do it. Like in general, max flow problems involve like creating a bipartite graph, creating range or something like that, and creating edges between them over there. Yes, that's correct. If we select any bulb in an SCC, we can turn on all the bulbs inside that SCC and all the edges pointing outwards from that SCC to the SCCB. Then we can turn on everything on the remaining SCCs as well. Like that's the main idea. And just SCC would be able to do this part where I am just creating, like I am running two for loops, trying to edge an edge between I and J if one of the J exists between I, and then finding the length size of the SCC which has only one. Like I have made some simplifications over here, like so source is only one over here. So thank you everyone for joining. Like I haven't really checked yesterday's problem again, so I don't really know how to do it yet. And I believe editorial would be out in some time. So, like I have ordered one mic and it would be delivered on Thursday. Let's see like the new one mic. How does it work? I hope the noise was bit clear, bit better compared to the previous videos. But yeah, I still know like it's not the best experience yet.